Welcome to today's lesson on compound inequalities. We're going to start by setting up our notebook. So I want you to pause the video now and find your notebook, preferably a spiral bound notebook or a binder where you keep loose leaf notebook paper. We're going to start by dividing our paper into 4 sections. So across the top, I want you to put one long line and you're going to put your topic heading at the top. Today's topic heading is compound inequalities. So go ahead and write that. And you're going to want to put today's date to the right-hand side. That will help you organize. Then at the bottom, I want you to go about 4 or 5 lines up from the bottom and draw a line straight across your paper and leave space at the bottom. This is where we're going to summarize main arguments and key concepts. And then I want you to go about 1.5 inches from that red line that goes down the side of your paper and draw another line down. This is where you're going to write any questions you have for me when I see you in class. Section 3 is where we take our notes. So I want you to have your pencil ready and be ready to write in section 3. Pause the video until you have your notes all set up. So inside of section 3, I want you to write yourself a little heading that says, why are inequalities useful? You don't need to write all the words for every single problem. That's actually not a very useful way to take your notes. You want to abbreviate as much as you can. So I want you to write example 1. You don't need to write that we're going to write and graph an inequality to represent the situation, but you should write the words. You should write, if you get 4 logs or more, you will receive a detention. That way later when you want to use this to study, you will actually know what it was that you were writing an inequality for. So let's think about what this means. If I get 4 logs, I will get a detention. If I get 3 logs, I will not get a detention. If I get 2 logs, I will not get a detention. But if I get 5 logs, or 6 logs, or 7 logs, I will. This is called an interval. I will get a detention if I have exactly 4 logs, but that doesn't summarize the situation. I can't use an equal to sign. I have to use an inequality. I need to show that it's greater than or exactly equal to 4 logs to get my detention. To graph that, I'm going to make my number line. I'm going to put 4 on the number line. Since I'm including 4, if I get 4 logs, I get a detention. So I want to shade that in to show that I'm including 4. And I want to shade to the right to show that it's all the numbers that are greater than 4, 5, 6, 7, 8, and so on. I do not get logs when I have 3, 2, 1, or 0 logs, which is why this isn't shaded. So now let's go to example 2. Again, you're going to abbreviate example with EX. You don't need to write the words write and graph an inequality to represent the following situation, but you should write, you can only attend Riverside High School if you are in grades 9 to 12. It is perfectly okay to abbreviate. Riverside High School could be RHS. Go ahead and pause the video until you have that written down. Now this time let's think about what that means. I have grades 9 at Riverside, but I don't have grades 8. I also have grades 12 at Riverside, but I don't have any freshmen in college. Students who are in college do not go to Riverside High School. But you also could be in grade 10 or grade 11. This is what we call an AND problem. You could be anywhere in between 9 and 12. This is also what we call a between problem. I could go to Riverside if I'm in between grades 9 to 12. I can use the word between to help me set up my inequality, to set up my interval. I don't want to write all the numbers that are in between 9 and 12 to show that, so I'm going to replace those with a variable. And I want to show that those numbers should either be less than or equal to 12 or greater than or equal to 9. A lot of you are going to notice that that's a less than and not a greater than sign, but think of it this way. 9 is smaller than the other grades. So 9 is less than 10, is less than 11, is less than 12. So we're always using less than signs for in between. This is what we call a between or an AND problem. All right, let's try example 3. You're going to abbreviate that example 3. You do not have to write all those directions. Write and graph an inequality to represent the following situation. You can have your phone out at school before 9 a.m. or after 4 p.m. This is what we call an OR problem. We can't both be before 9 a.m. and at the same time after 4 p.m. It's impossible for that to be a thing. So this is what I call, which is not mathematically correct, an out-between problem. We're looking at the outsides. So I can have my phone out before 9 a.m., like at 8 or 7 or 6, or after 4 p.m., at 4 or 5 or 6. But I could not have it out at, let's say, noon or 1. So I would not want to include the things that are in between. I would want to include the things that are out between. The only way to show that is to use the word or in between two separate inequalities. I can have my phone out before 9 a.m. or I can have my phone out after 4 p.m. I use less than for before and greater than for after. Now let's drill down and think about our times here. Could I have my phone out at exactly 9 a.m.? No, I could not. 9 is actually not one of my options, but I could have it out at 8:59. So I want to show that using a less than. I can have my phone out right up to 8:59, but not at 9. But I could have my phone out exactly when that bell rings at 4. This is what I call, again, not mathematically correct, an out between problem. The mathematically correct word is that this is an or problem. Now let's talk about shading. This should have been in between 9 and 12. To show that, I'm using my shaded in circles because I'm including grades 9 and 12, and I'm showing everything in between. This is out between, and this will show you why I call it out between. It's on the outsides of 9 and 4. There is no line underneath my inequality, so I use an open circle there to show less than. There is a line on my inequality, so I show a shaded in circle there to show greater than. All right, let's move on to a new topic. So still within that section where we're taking our notes, we're doing a new example. So you can abbreviate that example 1, but we're no longer talking about real life inequalities. We're talking about graphing an OR inequality. So you need to write the things that I underlined, but it's okay to abbreviate. The directions here say to graph the interval represented in inequality notation on the number line. You don't have to write all that, just write graph. Interval just means some section of the graph that we're going to be shading in. This is an OR problem. That means I want to be putting this out between. By the way, if you didn't write this problem down, go ahead and pause the video and do that now. And then you're going to want to draw a number line on your paper. It is okay to not make this detailed graph. On your own graph, you can just draw in your number line and include the relevant numbers, -10 on the left, 7 on the right. I'm going to show it on this detailed number line first and then show you how to put it on your paper. Show the things that are less than -10. I want to put an open circle because I'm not including -10 and shade to the left for less than. Or a number could be greater than 7. I'm going to put an open circle on the 7 and shade to the right to show the numbers that are greater than 7. Excuse me. Again, I used an open circle because there's no lines underneath my inequality that tell me to include -10 or 7. This is an out between is what I call it because we shade on the outsides, not an in between where we shade in the middle. This is an OR problem because a number cannot both at the same time be less than -10 and also greater than 7. It's impossible. Now on your paper, you can put open circles on -10 and 7 and shade to the left and shade to the right. All right, abbreviate this example 2, and you're going to write a new heading, writing an OR inequality. You do not have to write this whole set of directions, but make sure that you understand them. It says express the interval shown on the number line in inequality notation. Well, inequality notation is just telling you to use less thans and greater thans. Nothing's exactly equal to here. These are intervals. First of all, you know it's an OR, which is telling you it's out between. We're shading out between. This is an OR problem because we're shading out between, shading on the outsides of the numbers, which means I can treat each interval separately. I can look at this one separately from this one. By the way, if you haven't already written your number line, you should do that now on your paper. Remember, it's okay just to include the relevant numbers. You should have a -5 here and a 4 here. These should be shaded in circles, and you're shading on the outsides like this. To show that I want the numbers that are smaller than -5, I want to use a less than sign, and I am including the shaded in circle, so I need an equal to. For this one, I want to show the numbers that are larger than 4, so I use greater than 4 there. I need the equal to sign here because I have a shaded in circle on 4. All right, example 3, you're going to abbreviate this. Example 3, you're going to write your heading, graphing an and inequality. Again, we're graphing an interval, a shaded area based on this inequality notation. So write this inequality notation down on your paper. This is an and inequality. A number could be both greater than 2 and smaller than 9. We're shading in between here. The x is in between the two numbers. So on your own paper, when you make your number line, you can draw a simple number line like this, put your two numbers. Now, I don't see an equal to sign underneath this inequality here. That one doesn't exist, so we're going to put an open circle on the 2. Same thing with the 9, open circle on the 9. And this is talking about the numbers in between 2 and 9, so I shade in between. If I were to put this on this more detailed graph, it would look like this. Last example, we're going to talk about writing an and inequality. It says express the number shown, the interval shown on the number line in inequality notation. This is a between problem, which is an and problem. I can have a number that is both larger than -2 and at the same time smaller than 10. So I want to show this in this way. It's always the same template every time. By the way, if you haven't written down this inequality, you should do it on your paper now. We're in between -2 and 10. These both have open circles and we've shaded in between. Once I do that, it actually makes this inequality a little easier to see. I'm in between -2 and 10, and then I'm checking my open circles, which means I don't need less than or equal to signs, I just need less thans. All right, to wrap up your notes, you should write any questions you have right here. Where did I get this? What's an in between? What's an out between? When do I use an open circle? When do I use a closed circle? Any questions like that should go along the side next to the example that you had a question on. Then for your summary, it says when do you use an open circle and when do you use a closed circle? So let's think that through. I use an open circle when I have less thans or greater thans. I use a closed circle when I have less than or equal to or greater than or equal to. And then it says, what is the difference between an and inequality and an or inequality? I'm going to have you write the answer to that summary, and then we're going to discuss here in a few minutes.